morning, my dear friends. So today we are continuing the some basic concepts of chemistry, and this is the last video. So this concludes our today's video concludes our some basic concepts of chemistry chapter. So whatever today I am dealing, it will be the end of this chapter. And if you are having any doubts, you can ask me, or if you feel something is left, we will continue that when we meet face to face. Okay. And today what I am explaining, this is important, and for your kind information, since from many of the years, this question will be the one of fixed question in the annual exam. Definitely it will be there for minimum 3, and sometimes it will be asked for 4 marks. So probably I observe that it will be asked for 4 marks, but you should keep in your mind, for at least 3 marks this problem will come. So today we are going to solve only one problem. So you are come to know it's one of the very easiest problem, and I will give you the homework of same kind of the problem. Later I will send you that problems. Okay. So before we begins that important, let's look at the meaning and definition, heading of some basic concepts of chemistry. In that today we are doing empirical formula for molecular formula. So empirical formula, what is empirical formula? So you are familiar with the molecular formula. So molecular formula is nothing but, no doubt, the water has the molecular formula H2O. So here in the H2O, the number of hydrogens are 2 and oxygen is 1, means 2:1. In this ratio, hydrogen and oxygens are there. So water contains only 2 hydrogen and 1 oxygen is there. So this is the molecular formula of water, but we don't know how many moles of water we are taking. It is not matter. So only water formula is H2O. How many H2O waters we are taking, we don't know. If it is 2 H2O, means the ratio will remain same thing, because hydrogen becomes 4, oxygen becomes 2. Even on dividing this one, we are going to get the same ratio. If we are taking 3 moles of H2O, again we are going to get the same ratio. But the difference in the empirical formula is C6H12O6. So this is one of the molecular formula. So here, just to take the ratio, how many carbons are there? If carbon is 1, means 6 carbons are there. 6 2s are 12, means how many carbons are there? That double is hydrogen is there, and ratio oxygen and carbons are 6 only. Therefore I am writing 1:2:1. So these are the ratio. It means according to the carbon may be 1 and hydrogen may be 2 and oxygen may be 2, or carbon if it is 2, hydrogen is 4 and oxygen is also again 4. If carbon is 3, hydrogen is 3 2s are 6, again oxygen is 3. Can you see here? This is the molecular formula actually we are having, and the ratio of this one is 1:2:1. So this is the ratio. No doubt this molecular formula is having the carbon, hydrogen, oxygen in the ratio 1:2:1. Similarly, the same ratio follows the carbon is 1, hydrogen is 2, oxygen is 1. Can you see here? Carbon and oxygens are 1 and hydrogen is 2. Here also carbon and oxygens are 2, hydrogen is 4. Carbon and oxygens are same 3. The double of that is hydrogen. So it means that the ratio remains same. If we are writing exactly the formula of C6H12O6, then we are calling that as molecular formula. This is called as molecular formula. The same ratio if we are writing for lesser number for simplest carbon atom, means whole number, we are not taking the rational numbers, we are not taking the fraction, we are taking the whole number, means 1 2 3 4 like that we are taking. So the same ratio follows this formula also. So this kind of only carbon 1, oxygen is 1 and hydrogen is 2. So this is also follows the 1:4:1. No doubt it follows the ratio, but it is not the molecular formula, but it is simply follows the ratio. Such kind of formulas are called as empirical formula. So empirical is nothing but it is the formula which undergo the same kind of ratio with the simple smallest whole number. Simple smallest whole number. If we say C2H6, the ratio of carbon is, means number of carbons are 2 and number of hydrogens are 6. So we can write this in the ratio 1:3 because 2 1s are 2, 2 3s are 6. The ratio of C2H6 is 1:3. 1:3. If the molecular formula is exactly C2H6, C2H6, can you see that carbon atoms are 2 and hydrogens are 6? This is called as ethane. So ethane is having the molecular formula where the carbon and hydrogen contain the ratio 1:3. So ethane formula is this one. We know it is ethane, but we don't know what is the compound given. But simply they will give you the percentage 1:3. So 1:3 is nothing but carbon is 1, hydrogen is 3. So it may be a CH3 or it may be a C2H6 or it may be a C3H9. So these all are follows the 1:3 formula. So here the smallest one is CH3. CH3. This is called as empirical formula. So empirical formula is nothing but it is the simplest whole number formula which will be used to calculate or to determine the molecular formula. So what is that? How we are calculating? We will come to know in the soon. Means that is why we are solving that in the form of problems. So let's begin how to determine, how to calculate the molecular formula using empirical. Means they are not giving empirical. We have to determine that in the use of ratio. So let's start. This will be the important for your annual exams. Look here, this is one of the problem. This is, I said that it will be the important for your annual exam. So question will be same, but they are going to change the numerical value. So once you thorough for a single problem, you will be able to solve any of the problem because it will be the easiest problem. And moreover, you have to concentrate how you have to convert what you have to do. So this is how the important is. So let's begin the problem. A compound contains 4.07% of hydrogen. So they have given the hydrogen in the form of percentage. How many percents are there? Hydrogen is total out of 100%. The hydrogen is 4.07% and 24.27% of carbon. So carbon containing 24.27 and chlorine containing 71.65%. So they have given this data: hydrogen, carbon and chlorine. These are in the percentage they have given, and its molar mass is 98.96 molar mass. So here molar mass is nothing but the mass of 1 mole of compound is called as molar mass. Mass of 1 mole. So if you are taking water formula is H2O. So 1 mole is nothing but only H2 and oxygen is 1. 2 H2O is called as 2 mole. 2 mole. 3 H2O is nothing but 3 mole. Exactly 1 mole. Any of the component is 1 mole mass itself is called as molar mass. Means they have given hydrogen, carbon and chlorine. We don't know how many hydrogens and carbon oxygens are there. Means how many hydrogen, carbon and chlorines are there. But they have given the percentage. Based on percentage, we have to calculate the exact number of hydrogen, carbon, chlorine using the percentage, and they have given the molar mass is 98.96. And they have asked us what are its empirical and molecular formula. Empirical formula is nothing but first we have to find out the molecular mass. We need empirical formula. So first we will calculate the empirical formula. With the help of empirical, it's possible to convert, create a molecular formula, exact molecular formula with the help of molar mass. So let's begin. I request you somewhere you just watch the video and write the problems so that in the next while I am doing the solution, so it's not visible. For that reason, only thing is you should know percentage of hydrogen, carbon, chlorine and molar mass. Got it? So see the solution. So look here, to this problem, the solution is you have to draw the chart. So this is the chart is important. You have to practice this chart and what you have to write. This is the important thing in this solution. Look here, the solution, in this solution first I have written as the elements. So elements whichever the present in this problem means in the form of percentage they are given, you have to write the element name. Next you have to write the percentage of atoms in the compound. They have given some percentage. What are the percentage of hydrogen, carbon, chlorine you have to write. And you have to convert the percentage which how much they have given. The same percentage you have to convert in the form of mass. If they have given 4.07 percentage means you have to write the percentage as gram, 4.07 gram. So convert it. Next, number of moles of each element means we have to calculate the number of moles by using the formula. So given mass divided by molar mass, it gives the mole formula. So based on that, what we have to do the next I will tell you. So look here, the first one, the elements present in this problem is hydrogen, carbon and chlorine. Therefore I am writing the elements present. This first one is hydrogen, next one is carbon. We can write H2 or generally we can write the sentence hydrogen, carbon and chlorine. Whenever you are writing the hydrogen and chlorine, you must use the diatoms. You are not supposed to use H or Cl. You have to write H2 and Cl because these are the gases compound, they exist in the atoms, whereas carbon exists in a single atoms. So next one, the percentage of atoms in the compound. So what is the percentage of the atoms? So in the percentage means they have given some percentage. How many percentage of carbon is there? How many percentage of hydrogen and chlorine is there? Just look here. The hydrogen percentage is 4.07. Therefore 4.07. This is percentage. Carbon is having 24.27. 24.27 percentage. Next one is chlorine. Chlorine is having 71.65. 71.65 percentage. So this is the percentage. And next one is convert the percentage into mass. Simply just instead of writing the percentage, you just write the mass in the form of gram. 4.07 percentage is converted as gram. Similarly, 24.27 gram. Chlorine is 71.65 gram. Can you see that simply I have converted percentage in the form of mass. And next one is number of moles of each element. So look here, I think you are familiar. If it is new thing means just learn this one. So number of moles is nothing but oftenly I have using the examples of water. So H2O means if nothing is written coefficient. So H2O is not mentioned how many H2Os are there. If not mentioned means it's understood one will be there. So H2O means 1 mole. 2H2O means 2 mole. So similarly, you have to calculate the number of moles of each element. Means how many hydrogens, how many carbon and the chlorines are there. How means to calculate this mole means N. You have to use the formula small m upon capital M. Otherwise we may call this as W upon capital M. So what is W? Or generally we are writing M upon capital M. So what is M? M is nothing but it's a given mass. Given mass means in the example whichever they have given, that mass is called as molecular mass. Molecular mass. Whereas molar mass is nothing but it's a mass of one atom or mass of the compound. So given mass divided by molar mass. By dividing this one, we are going to get the number of moles of that atom or that compound. So similarly, the first one here is how you have to calculate. N is equal to means number of moles you have to calculate. N is nothing but small m upon capital M. Small m is nothing but given. How many hydrogens are there? It is 4.07. 4.07. It is given mass divided by. So each of the hydrogens masses. What is the mass of hydrogen? A single hydrogen is having the mass 1. So 1 is not the accurate but exact molecular mass of hydrogen is 1.008. 1.008. This is the mass of one hydrogen. Therefore, by dividing this one, we are going to get slightly 4.04. 4.04. This is the number of moles of hydrogen present in this compound. Similarly, number of moles of carbon. First one, n is equal to m upon capital N. Small n is given mass, that is 24.27 gram divided by 1 carbon is having the mass. The mass of one carbon is 12. We are familiar with about that 12 gram, but exactly the mass of carbon is 12.01. 12.01. So by dividing that one, 12 1 12, 12 2 24. So we will write 2 point, again 27 will remains. By calculator we can do that one, because it will be easy, and you are obviously can have the permission to use the calculator. Better use the simple one, because scientific is not allowed. I hope you are getting 24.27 divided by 12.01. We are going to get value 2.01. So this is the number of moles of carbon present is 2.01. Third one is n is equal to m upon capital N. So n is nothing, m is nothing but given mass, that is 71.65 gram divided by the molar mass of chlorine. Each of the chlorine is having the molecular mass, means mass of the chlorine is 35.5. So by dividing this one, again 35 2 is 70. Here it is 0.5 is there. So around 2 we are getting same 2.01 we are getting. So if you are not able to do it, you can do the calculator. With the help of calculator, the answer is 2.01. So these are the number of moles of hydrogen, carbon and chlorine present in the compound. So this is, we have calculated the number of moles of each element. How means by dividing given mass divided by molar mass. So we are going to get the n. That n itself is called as number of moles. Next one is divide. Can you see that? I am written in the symbol for divide each mole. Mole, these are the number of moles. Divide each mole by smallest. I have written 2 times. Smallest mole value. Smallest mole value. So these are the number of moles of hydrogen, carbon and chlorine. Among these three, which one is smallest number of moles? This is 4, this is 2, this is 2. These two are having a same number. If it is any one is having the smaller number, by that number you have to divide all the three. So here 4.04. You have to divide this one by the smallest. These two are the smallest. You can take any one. So divided by 2.01, you are going to get 2 1 2, 2 2 4. Therefore, nearly you are going to get 2 answers. So similarly, 2.01 divided by the same again, the whole number 2.01, we are going to get 1. 2.01 divided by 2.01, same we are going to get 1. So this is going to tell us number of atoms in the compound. This final answer is going to give you. I will show this one. These are the number of moles of the carbon, hydrogen and chlorine. These are the number of moles. How many atoms are present? That can be calculated by dividing each of the number of moles by smallest mole of among these three. Smallest mole. So totally here it is 3. If it is 5 means you can take the 5. Among those 5, which one is having the smallest number of moles? In that, using that one, you have to divide the remaining all. So including that also, 1 2 3. These two are the smallest number, because these two are having the same value. Therefore, I am dividing the first one by the smallest value. We are going to get the 2, and second one is by smallest value. We are going to get 1. Similarly, third one also we are going to get 1. So what is this 2 1 1 indicates? This 2 indicates the number of hydrogens. Number of hydrogen in the compound is 2, and 1 is nothing but the number of carbon and chlorine in this compound is 1. So based on this value, it is possible to write the empirical formula. So empirical formula is nothing but is the simplest form of atoms present in the compound. Therefore, empirical formula, I am writing the short form. Empirical formula is equal to, first one we have to write the carbon. Carbon, how much carbons are there? One carbon is there. So I am writing only carbon. C. Carbon is there. C1 is nothing but simply C. And hydrogen it is 2. H2. And chlorine it is 1. Therefore, CH2Cl is itself called as empirical formula. So keep in your mind, this is not the exactly number of carbon, hydrogen, chlorine, but it's going to give the ratio. Means carbon is 1, hydrogen is 2, chlorine is again 1. So 1:2:1. Carbon, hydrogen, chlorine, they are in the ratio 1:2:1. So here, using the empirical formula, so in empirical formula, the carbon and hydrogen and chlorine are in the ratio 1:2:1. So means carbon is 1, hydrogen is 2, and chlorine is 1. So using this one, we can able to calculate the molecular formula. So molecular formula can be calculated with the help of number of moles. So how means, you just see the final answer by this value we are going to get the empirical formula. This is the answer for the first question. Means they have asked two. What is the empirical formula and what is molecular formula. So this is the empirical formula. This answer is nothing but this is of the empirical formula. So using this empirical formula, we can write the molecular mass of empirical formula. So mass of the empirical formula is nothing but this is the empirical formula. We have to do the sum of masses of carbon, hydrogen and chlorine present in this compound. Means the number of carbon is 1 and hydrogen is 2 and chlorine is 1. So carbon carry the mass is, how much it is? 12 gram. Can write directly. Carbon is 12, hydrogen is 2, chlorine is 35.5. By doing this sum, we are going to get the masses of empirical formula, that is 49.5 around. Exactly we are getting is 49.48. So we can write that 49.5 gram. So this is called as mass of empirical formula. So using this one, what we have to do is, N means number of moles. Number of moles of the compound which is multiplied to the empirical formula. This empirical formula, we are going to get the molecular formula. So this is how we are going to get the molecular formula. Molecular formula can be determined with multiplying this empirical formula by number of moles. How we have to calculate number of moles means, N, you just send this empirical formula to the right side. So it becomes divided, empirical formula divided by molecular formula divided by empirical formula. So here I am writing the molecular formula in the form of molecular mass. So molecular mass of this compound means given that itself is a molar mass. Means molecular mass is nothing but it is exactly 1 mole of the compound. So here given molar mass itself is the molecular formula's mass, means mass of molecular formula. Mass of molecular formula is nothing but molar mass. So molar mass and mass of empirical formula, I am writing empirical formula mass. So we know that they have given the molar mass value. So given molar mass value is 98.96. That's why I have written here 98.96 divided by, this is empirical formula mass we have determined 49.5. So multiplying these two, we are going to get around value is 2. Means number of moles N is equal to 2. So we have to write this in this formula, N into EF, we are going to get MF. So N into empirical formula. So you have to write, I have written, due to this shortage of space, I have written EF. So whenever you are writing, you have to use that long sentence. Means you have to write compulsory empirical formula only. Don't use that short form EF. So N is nothing but as it is N only, because number of moles it is into bracket empirical formula, that gives the molecular formula. So N is nothing but here it is 2. Empirical formula is nothing but whichever we have calculated, CH2Cl. Carbon is 1, hydrogen is 2, chlorine is 1, CH2Cl. So whenever we are writing any formula, first actually we have to write carbon first and remaining is next. So first carbon, next hydrogen, next is remaining. If it is a chlorine, nitrogen, oxygen, it will come after N. Therefore, I have written carbon first, CH2Cl. So N is 2, just you do the multiplication. Below the C, if nothing is there, means 1 will be there. So 2 1 ja 2 I have written. Below the hydrogen 2 is there. 2 2s are 4 it is. Below 4 nothing is there, it means 1 will be remains. So 1 2s are 2. Therefore, the molecular formula itself is C2H4Cl2. This is called as molecular formula. This is the second question they ask. First one is calculate the empirical formula. Up to sometimes they will ask you only the calculate the empirical formula for 2 months or at least 3 months. At that time, you have to calculate this one and you have to stop this one. So here, up to here it is determination of empirical formula. To calculate the molecular formula, you have to calculate mass of empirical formula and you have to divide molar mass by empirical formula. Definitely they are going to give you the molar mass. Using that one, you have to divide molar mass by empirical formula's mass of empirical formula. So you are going to get the n value. That n you have to multiply it with the empirical formula. You are going to get the formula. That formula itself is the molecular formula. I hope can you able to understand this one. So this is the important simple method. But what you have to concentrate is whichever they have given the problem, just look at. Definitely they will give you in the percentage only. Sometimes they will give you directly the gram. If they have given grams, you just remove from this table. Means the given elements, whichever they have given, just you write as it is. Elements, name of the element. If they have given percentage, you just put this column, and after this you just convert the percentage into the gram. Sometimes they will give you directly gram. If they have given gram, you just eliminate this group and directly write the mass of given elements. In that name you just write mass of the given element. And next one is calculate the number of moles of each element. How means given mass divided by mass of the single element. And by this number of moles you just divide the from smallest number. So smallest number used to divide each of the number of moles. So we are going to get the whole number of atoms present in that compound. So this indicates the number of atoms in that compound. So using this value, you can able to directly learn the empirical formula. This 2 indicates that hydrogen is 2 atom, means percentage it is 2 ratio, and carbon is 1 and chlorine is also 1. So using this one we have written the empirical formula, and using this we have calculated the mass. So next is molar mass divided by empirical mass, and n we are going to get that n will be the multiplied n into EF, it gives molecular formula. So I hope this is clear. So if you are having any doubts, you can ask me. If any confusion arises in between, so that I will clear your doubts. Okay, this is important for 3 to 4 weeks. So the next one is very simple concepts are there. These are the definitions: molecularity, moles, molarity, number of moles, and mass percentage. It will be asked for 1 month. And one most important definition is the limiting reagent, and simply the calculations are there. So this will carry around 10 to 15 minutes. So I am thinking that to continue the next one in another video. So why? Because the next we will be having the exams on this chapter. So that from chemistry, this one chapter will come, another will come based on the madam, how she has completed our on one chapter. So better let me conclude this chapter by the next video. So next video will be your last video on first chapter. So if you are having any doubts on that, means you just text me in your WhatsApp group, so that I will clear that your doubts in this video, means in next video. Okay, have a nice day. Bye.